So we'll try to find out the limiting value of this function square root of x minus 2 divided by x minus 4 when x approaches the value 4. So let us begin by first plugging in the value of x with 4. So we'll square root of 4 minus 2 divided by 4 minus 4. So square root of 4 is 2. So we have 2 minus 2 divided by 4 minus 4, which is an indeterminate form, 0 over 0. So that means we need to do a little bit of algebraic manipulation to our function. So what we will do, so we will take the numerator, which is square root of x minus 2, and multiply to its conjugate, which is square root of x plus 2. Now, this being an extra term, we also need to multiply it to the denominator. So we have square root of x plus 2 in the denominator as well. Now, the whole reason of doing this is now in the numerator we have an expression of the form a minus b times a plus b, where our a is represented by square root of x and b is 2. So this is actually a squared minus b squared. So that means we have square root of x whole squared minus 2 squared. That means on the numerator we will have x minus 4. So let's place this value. So we have limit x approaching 4. Then the numerator we now have x minus 4 divided by x minus 4 times square root of x plus 2. So this x minus 4, which is a common to both the numerator and the denominator, they both get cancelled out, and this leaves us with limit x approaching 4, 1 over square root of x plus 2. Now let's plug in the value of x with 4. So this gives us 1 over square root of 4 plus 2, and this is equals to 1 over 4. So this is the limiting value of this particular function when x approaches 4. That means in the vicinity of x equals to 4, the value of this particular function is 1 over 4. Let's move on to the next problem. So here we have the function x squared plus 2x minus 15 over x plus 5, and we have to find the limiting value when x approaches negative 5. So same as the previous problem, we always have to begin by first substituting the value of x with the limiting value of x. So we have negative 5 squared plus 2 times negative 5 minus 15 divided by negative 5 plus 5. So we have 0 over 0. This is the indeterminate form. This simply means that our function does not exist at x equals to negative 5. So next what we'll do, we'll try to do some algebraic manipulation and try to find out the value of this function in the vicinity of x equals to negative 5. Now, if we consider the expression in the numerator, which is x squared plus 2x minus 15, when we factorize this, we get x minus 3 times x plus 5. So this is divided by x plus 5. In doing so, we see that x plus 5 gets cancelled out from both the numerator and the denominator, and that leaves us with limit x tend to negative 5. So we have x minus 3. So we substitute the value of x with negative 5. So we have negative 5 minus 3, and this is giving us the value negative 8. So we say that in the vicinity of x equals to negative 5, the limiting value of this particular function is negative 8. Let's do another problem. So here we have a rational function, but this time we have to find out the limiting value of this rational function when x approaches infinity. For this, all we have to do is look for the highest power of x in any of the numerator or the denominator. So clearly, if we consider the numerator or the denominator, we see that the highest power of x is x raised to the power of 7. So what we'll do, we'll divide both the numerator and the denominator with x raised to the power of 7. So that means our expression now becomes, what we'll do, we'll divide each of the terms in the numerator with x raised to the power of 7. So that gives us 8 minus, so we have 5 times x raised to the power of 4 divided by x raised to the power of 7 plus 2 divided by x raised to the power of 7. whole divided by, so since we are also dividing the denominator by this x raised to the power of 7, so dividing each term with x raised to the power of 7 gives us 4 plus 3 times x cubed divided by x raised to the power of 7 minus 1 divided by x raised to the power of 7. Furthermore, we get limit x approaching infinity. So we have 8 minus 5 over x cubed plus 2 over x raised to the power of 7 divided by 4 plus 3 divided by x raised to the power of 4 minus 1 divided by x raised to the power of 7. So what we do? We use the limiting value x approaching infinity. So that means we substitute the value of x with infinity. So the second term and the third term in the numerator, they goes to 0. So does the second and the third term in the denominator. And that simply leaves us with the value 8 over 4. And this is equals to 2. So that means when we have x approaching a very high value, then this function, this rational function, approaches the value 2. Let's do another problem. So we again need to find out the limiting value when x approaches an extremely high value for this particular rational function. So we look for the highest value of x in both the numerator and the denominator, and we see that the highest power is x raised to the power of 5. So we have to divide each terms of the numerator and the denominator with x raised to the power of 5. So in the numerator we have 1 plus 6 divided by, so x squared over x raised to the power of 5. So this will give us x cubed minus 3 divided by x raised to the power of 5 all divided by, so in the denominator we have 3 divided by x plus 7 divided by x raised to the power of 5. Since x is a very large value, so that means we have 1 plus, so 6 divided by an extremely large value cubed, that will give us 0, minus 3 divided by a very large value, so that will give us 0, divided by, so we have 3 divided by an extremely large number, so this is 0 plus 0, and we have 1 over 0, and since this is divided by 0, we will consider an undefined value. So we'll say that the limit is undefined. So let's move on to the next problem. So let's find out the limiting value when x approaches an extremely large number, which is infinity. So we see that the highest power of x in both the numerator and the denominator is 7. So we have to divide both the numerator and denominator by x raised to the power of 7. So in the numerator we have 1 divided by x squared divided by, in the denominator we have 1 plus 7 divided by x raised to the power of 7. So we have 1 divided by infinity squared, so this will be 0 in the numerator, and we have 1 plus 0 in the denominator. So this is going to give us the value 0. So this is the limiting value of this particular rational function when x approaches an extremely large number. Let's move on to the final problem. So we have to determine the value of this function sine 5x over sine 2x when x approaches 0. So first thing first, if we substitute the value of x with 0, so we have sine 0 over sine 0. And we know the sine of 0 is simply 0. So we have an indeterminate form, 0 over 0. So in order to solve this particular limit, we are going to use something called the sandwich theorem. Although the proof here is not mentioned, but the sandwich theorem simply states that if we have a function sine of x divided by x when x approaches 0, then this limiting value of this particular function approaches the value 1. So we are going to use this particular value of sine x over x to solve this numerical. So what we can do, we can rewrite this as sine 5x divided by x. All we have done is we are going to divide both numerator and denominator by x. And the next step, what we are going to do, we are going to, instead of x in the numerator, so we will have 5x, and for that we are going to multiply with the factor 5. And then in the denominator we have sine 2x, so and divided by x. So the x in the denominator will be replaced with 2x, So that means we also have to multiply with the value 2. So this gives us 5 over 2 times. Now what we can do, we can apply the limit separately to the numerator and the denominator. So that means we have limit x approaching 0 sine 5x over 5x divided by limit x approaching 0 sine 2x divided by 2x. Using this value, so this will go to 1 and this will also go to 1, and the final limiting value is going to be 5 over 2.